The other thing we're going to talk about today is search. No surprise that the App Engine has a good search capability, given that it's made by Google, and search is what Google does. It turns out that the way they have search set up is very similar to other search implementations. For example, Elasticsearch is a very common search product that a lot of companies use to implement search, and so some of the concepts and the way it works is very similar, and so I think this is generally applicable to other search capabilities. But before we talk about search, I want to sort of do a refresher on indexes. Does anybody remember what an index is? Describe an index. So what's an index for? Why do we have an index?
To search for locations.
Yeah, it makes digging through a large amount of data more efficient. So let's think about what indexes are. It's not like a specific computer thing. It's a general concept. It's like a
provides for a unique identifier for each record.
Yeah. So let me give you some examples of indexes. And there's always this confusion: is it indices or indexes? I don't know. We're going to call it indexes. So imagine you have a dictionary, right? And a dictionary is a list of words with definitions. And so we have, aardvark and bat and cat and so on, right? We have, thousands, hundreds of thousands of words. I don't know how many words there are, but there's a lot. And one of the ways we structure a dictionary is alphabetically. So these are in order alphabetically. And the index would be the letters. And we'd say A is on page 1, and B is on page, 103, and C is on page 211, right? And this, we find at the beginning or the end of the book, right? So we're stored the whole dictionary, and then on the last few pages we store this table of contents, which is an index. So this is the index. Okay. We do that because it makes it easier for us to look up a word. Rather than start at the beginning and go until we find it, we can jump to the right page. Okay. Now, maybe with a dictionary that's not the best example, but if you're thinking about an encyclopedia, maybe it starts to make more sense, right? Because now I can look and see, oh, this book contains this thing, and now there's like 13 books, and so in general, the more information you have, the more important an index becomes. Because getting through all the information can take forever if you have a lot of information. Right? And so, what are other examples of an index? Can anybody think of any?
Well, I've heard that the Library of Congress had their card catalog on a couple CDs, and instead of like looking for a word and finding the word in the catalog, they had an index at the end of each word and all the numbered references where it appeared in the catalog, and that was an easier way to find the words, to have that index of locations than to actually have to search for it.
Yeah. So
that's more of a full text index.
Yeah.
there's like the what do they call it? The Dewey whatever system, and then the one they use in most libraries with the number.
Yeah, but this is like a full word index, like you said.
Oh, okay.
Locations of each word that was in the entire catalog.
How about aisle numbers at the hardware store?
Exactly. So there's lots of them, and in fact, the sort of quintessential one is Google itself is a big index. Right? You search for something, it finds you web pages related to what you're searching for. And so, because there are billions of web pages, there's no way you could find it by just starting at the first one and going. Right?
So it includes an index of all those pages?
Yeah.
Yeah.
A very, very large index that's updated every single day and has a very good search capability. So this is an easy thing to build, this kind of index, because it's by letter. Building one that understands what you mean is much harder. But the basic idea of huge amount of data and a smaller amount of data is the index. Okay? So for search, we have these four fundamental concepts that we work with: our documents, indexes, queries, and results. Okay? So documents are the things that we're indexing. So in our case, for this, they're the word and the definition, maybe, or in this case, just a word. But in the Library of Congress, it might be the book that they're a part of. This is the document. And then the index is the thing that's pointing to documents, makes them easier to find. And then a query is the thing we ask. Okay, so the query here is a letter. The query for Google is a search term, right? You enter it into the query box and you hit enter, and it gives you back results. So queries typically contain many different types of operators. The basic operators just search for a word, a term, a single word. But then you put a space, and that means both of them, or it might mean either of them. We might use special words like and or, right? I might say A and B, and meaning that I want to find documents that have both A and B. There's also lots of other operators. You can do words that are near each other, or words that are near each other but not followed by this word, or you can do all kinds of complicated queries. And so those are queries. And then results are, they're not usually the whole document. They're usually something like a summary of the document. So in Google, when I search for something, I don't see the whole web page. I see a little bit of description. And then I click the link to get the full page. So a result is that small blurb. And that's the basic idea of how search works. Any questions about the idea of indexing and search?
Well, one of the things I think about, because I've had a little bit of experience with SQL relational databases, is how, if you have a record, that record could have a variety of fields, first name, last name, address, phone number, city, state, zip. And then in that database, you can say, okay, one of the indexes will be the key field, the unique ID for each record, but then another index might be, I need to find people by zip pretty quick. So I'll tell the database to index that, and it'll keep a file of everything sorted by zip code, so that when I look things up by zip code, it can jump right to that zip code instead of having to go through and look at each one and get all the records at that point.
Yeah, so that's a similar idea. And we actually had indexes with data store as well, and it's doing the same thing.
Yeah.
The difference between that and search is those indexes are sort of manual and very straightforward in how they work. These indexes are more sophisticated because it's not just sorting by alphabetically. It understands queries in a pretty sophisticated query language, like I was saying, the A and the B and C. And so it's more sophisticated type of indexing, but similar idea. And like I said, in a real software company, when you're doing real web dev, you typically do not implement search using your database. You use a separate thing to do the search. Because it's such a different, it's not just, I want where the last name is this. I want where the last name is this, but if I misspelled the last name, it returns some results, and it can do the ordering, so it gives me the more likely correct answer. That kind of stuff is doesn't fit into the standard index model, right? I need a smart index, and so that's why we use search.
Some SQL databases will do a full text index field.
Yeah.
But usually if you do where thing is, where you can do part of it, it's gives you a full table scan.
Yeah, that's a good point, that some databases support, and they'll call it full text.
They're usually not very good anyway, though. Yeah. But yeah, someone will build an index on the text contents. But usually if you do where, I don't know if it's percent, whatever, the weird thing, where this is part of it, it scans the whole table. And so this is going to build you an index where you can say, I want Billy and Bathgate in the movie description. And it's going to say, this word's in this one, and that's going to get a list. The index server, the search server, and then it's going to get another list within those of the ones that have Bathgate. It's going to do the union of them and send it off to you. So it works much more quickly that way. It hits the disk list.
Yeah, so the documentation here under search, there's a bunch of stuff described. We're not going to do all these things because search can get pretty sophisticated. Like we're not going to talk about faceting and stuff like that, but we can do the basics of search. Faceting is what can tell you that of various types, the number of results that were returned and stuff. But we're not going to get into that, too much of that. So we're just going to do the basics. So it comes. Some of this is pretty specific of the way it's implemented. But I think it's kind of useful. So it says a document is an object with a unique ID and a list of fields. So a search document, a document for search, is very much like an entity in the data store. You have a unique ID, and it has fields. And those fields can have various types. Okay?
Or like a record in a database.
Exactly.
The document, entity, record, tomato, tomato.
All very similar concepts. Here, the restrictions are a little different because this is geared towards searching, and so the kinds of fields it supports are different. and how they interact with the search index are different. But that's described in more detail. You know, and it's telling you text field, HTML field, number field, and so on. This is kind of cool they have this supported. You can search for HTML, which turns out normally when you just throw search in when you throw HTML in a search product, all those tags and stuff throw it off, right? You know, you discover that documents contain the word strong a whole lot, right? It's like, well, that's not. So now when I look for the word strong, I find every document in my index because that's an HTML tag that's commonly used, not the word strong, which is what I was looking for, right? In other words, all that HTML formatting can throw off the search index. Okay? So it's nice they have that, and they also have other things. Like I said, no surprise that they would have that, right? They're Google. That's what they do. That is their fundamental business. So, of course, they know how to do that. So that, like I said, so you make this document, you can ID. Now the crucial thing here is that this is a different document. This is a different thing than the entity in the data store. So if I want to search using the search capability, I have to store my thing in data store, because that's where I'm storing it normally. I also have to store it in search. Two separate documents, okay? Two separate things.
Well, that sounds kind of bad practice.
Well, it's because they're very different. And typically, these documents are going to be bigger because the maximum size is a megabyte. You would not want to store a megabyte in the data. That was
So if we want something to be searchable, we store it in what's this even called? It's not data storage.
search.
So we store it in search. That's
Yeah.
a storage area.
Yeah.
And if it's too large, we store it in search.
So typically the things you want to search are different than the things you want to store in the data store. They end up being different things.
Okay.
And so, for example, if you were searching books, you wouldn't store a book in the data store. You'd store a book as a file in Google Cloud Storage. And then you might add some content of the book to your search index. And that way you could search for the book, and then when they click to download it, you get it from Google Cloud
All
Storage.
right. So say that again. So the book would be stored in Google Cloud Storage.
Yeah,
And that is different than data store. Cloud
Yes.
storage is
for files. It's like a big file system.
for files. Cool.
So we're storing it just as a file. So it's not an entity with fields, it's just a blob of bytes with a name
And then the portion of the book that we want searchable, we put into the search area.
as a document.
Would you ever like say, okay, I'm going to put the whole book over in cloud storage and then also the whole book in documents because I want it both searchable?
Maybe, because actually documents can be, says up to a megabyte, and that's, most books will probably fit in that. But
If you're familiar with, I mean, an analog is, you get to keep your title and author and price and everything in SQL Server, say. And then if you were doing this with parts outside of App Engine, the text search would be an Elasticsearch or OCD or one of those products. And that's same story. Right tool for the job, and this is where we're splitting it up on App Engine.
I'm not familiar with that, but I'm going to learn as we go.
yeah, okay, so an index stores documents for retrieval. It says you can retrieve a single document, so that's like get from the data store. We have that ability. We get a range of documents. We can get all the documents in an index, and then of course you can also search on it. That's the whole point. And they have this thing called a query string, which is perhaps an unfortunate name because we already think of query strings as something that websites do. This is a different query string. So just like there were different channels, now there's different query strings. This is the syntax it understands for querying in search, as things like the and the or and that kind of stuff. And then they say there's no limit of documents and so on. You can have different indexes. There's not just one index. I can index different things, okay? I could have an index for Wikipedia articles, and one for books, and one for Amazon blurbs of my products, and one for comments, and one, I mean, you could just have a different index for each thing in one index, okay? So there's not just one. And then here's the query. So, like I said, it could just be 2 words. It can also be more sophisticated. See this? Product equal P&O and price less than 5,000. So it's more than just searching for a single word. It has this language that it understands. And those are described here. All the things it can do. And it can do a lot. Talks about it. But, so this is the kind of thing you might just want to play around with and try to figure out what will be a good query. Sometimes we allow users to enter the query, and sometimes we don't. It kind of depends on the use case. In other words, we might give to the user the ability just to enter these directly, and we might give them a document that says, here's how you can search on our product, and it just so happens to support everything this does. Or we might do that for them. We might come up with our own and translate. I mean, it can get kind of complicated, but I think for all our examples, we'll just let it be the way it is. Okay. And like I said, we can play around with these. It usually does a good job just based on the single word. And some of this stuff is talking about things like this, stemming. This cat would combine both cat and cats. So it understands a little bit of English grammar, right? So that's what I mean by it's not just like a plain index you get in a database. It's smarter, anyway. So that's the basic idea. Like I said, it's described in detail here about how you do queries. But the point is, the API is pretty straightforward. You just do .search. Hand it that thing as a string, whatever it is, and it will do the search for you. Okay. Any questions about that? Everyone understand
So
the idea of the query
the
string?
rose water in the search there, that's the search term?
The query string.
The query string, yeah. And index.search, index is the package, or we will define an index and that'll be a method off of like an instance of something. Like how's it know what it's searching right there? What index is it searching?
Yeah, so index here is not a package.
Okay, so that's just whatever index.
Let's see if they have an example there. Here we go. They'll say .open, so search your package. They'll say .open, you'll give it the name of the index.
Okay.
And it gives you this index. And then you say index put, index get, index
Okay.
search. So it's relative to that specific index. Okay. But, okay, let's see. Yeah, and so there's more detail here, but maybe we should just look at some examples to get a feel for how you use the search product. It's actually pretty straightforward. So I'm going to make a search example. And we'll add our app YAML. So we'll just get him from here. Okay. Probably, I don't know, do we need login? I guess it doesn't matter. Okay, so I'm going to make a search.go package. All right, so we need some sort of handler. If I go to, before we can search, we've got to have stuff in our search index, right? And so maybe we'll start with that. So we'll have a /put here, and I will handle okay. So what do we start with? Get a context, right? Whenever we work with any of these APIs, we're going to need that. Right, because in the example here, get the context. And then we open the search index. So and we give it a name, so we'll just call this example. And that's going to give us an index and possibly an error. And so handle the error. And I'm just going to send this to the response so we can look at it, okay?
We decided that this is going to be a document search or is it an open search?
Open search?
I mean, it was going to be
The open here is the index name, opening an index. And then we're going to put something inside of it. Right. So let's run that. Right. I haven't done that, so slash put. Okay, that's some memory address and a bunch of other nil stuff. But we didn't get an error, right? So that's good. So now I have my index, and we can do index.put, okay? GTX, the ID, and what else does it take? Let's look at it in Godot. This is app engine/search, and then it's put is the. Okay, so put save source to the index. Source is what is this?
Any type.
Any type. So source can be anything. If ID is empty, a new ID is allocated. So that's nice. It's a human readable ASCII string. It must contain no white space characters and not start with a bang. That's kind of interesting restriction. Source must be a non-nil struct pointer or implement the field load saver interface. So we got to create a struct, and it's got to be a pointer. And that's the same as the data store, same kind of thing. So we got to create a type.
What are your thoughts on no exclamation point for the first character? That just seems.
They must use it for something special inside.
Yeah.
And this is interesting too. It's a human readable ASCII string. So I guess you can't use special symbols and stuff. But you could create one. You didn't have to give it one. If you gave it the empty string, it'd make one for you. So maybe we should do that. But we have to create a document. So I'm going to make a new type document. And suppose this has a couple fields, name, which is a string, and text, which is a string. Okay, so we're going to make a document. And the name will be example, and the text will be, let's get a lorem ipsum. You guys did lorem ipsum, didn't you? Did you guys do that?
Lorem ipsum will screw up stemming and stuff.
Things that kind of look like Latin but aren't really Latin.
Well, if we're gonna search it though, I guess we could just search for crazy Latin.
Yeah, lorem ipsum's got screw up stemming and stuff. You don't really.
Okay, let's go to Project Gutenberg and get a real text, huh?
I'm fine.
I mean, it's parsing, stemming and everything based on English, so
Oh, that's right.
fake Latin is
That's right.
gonna be garbage to it.
Sorry.
I have no idea what this is. What's a good book?
For whom the bell
War and
tolls.
Peace.
Moby Dick, we've already got that.
Yeah, we did that. Let's do something else.
Yeah,
Pride and Prejudice. Lady Chatterley's Lover. Just trying to keep it fresh and interesting, folks.
Okay,
What's that gray, 50 Shades of Grey?
Book of Roses and Shoulders.
okay, we got a book. We're going to just copy the first bit of this, okay? Okay.
I dare say, Mr. Bingley. Is this black tea?
Okay, so we made our document, and we have to put it in there, okay? And so we just pass it in, right? And what does this return? It returns a string and an error. What's the string going to be?
You guys need the whole book.
No, it's the ID.
The ID that it'll make up for us. So that's just like the put on the other one. So this will be the ID and possibly an error. So we're going to put it in there. We're going to give the empty string so it generates one. And let's look at this. So ID error. Right, context.
So that's all you got to do to put something in the search area?
Yeah, it's pretty easy. It should be. Cool. I've created an ID, no error. We can see what it was by going to the admin thing. Somewhere in here. Example, that's the index we created. And here's the document. And there's the text. right? So cool, we put something in there. It's pretty easy, right? Any questions about that? So this looks just like the data store put, right? Very similar. It can only be string keys, but otherwise it's very similar. Okay, so we can do a get, right? So let's make one for that. So I'm going to collapse this just because sometimes it doesn't understand strings so good. That's too bad. Okay.
That's all right, I had trouble understanding Jane Austen also.
Okay, so we're going to do the same thing here, right? And then we're going to get the same index. So, whoops. So, create a context and then open the example index. And then we just do index.get. You give it the context, the ID. What's the ID here? It's this thing.
Example,
No, we let it generate one, so it's this.
not the name.
That's, no.
Does this look
Index
familiar to
ID or
anybody else?
document ID?
What is that?
Index ID or document ID?
That's a document ID? What does that look like?
That's a UUID.
That's a UUID. See?
But is the parameter an index ID or a document ID? That's the
Document. This is the
Why
index
is
ID.
document ID?
This is the document. I'm doing a get. I'm getting a document.
Oh, you're getting a document after, oh, you just hard coding it, okay.
So let's look at get. ID destination. So what do you think's going to go in here?
And type, and then some sort of struct that we could, add a pointer to the struct where we can drop the example and the.
So let's pull out document. So we can use it in here. And we'll say var document, and give it a pointer. So ampersand document. This probably returns an error. Sure enough. So we'll just do that. All right. So we'll print this to the response and see what we get. I expect that we'll get the same thing, right? So I did a put, and it gave me back this ID. Now I do a get, and it gives us back this, which is what we put in there, right? I mean, so get and put, very similar to the data store, pretty much identical, and it's a little bit different in what you pass, but otherwise the same idea. Of course, the main thing we want to do is search, right? So.
I feel like making more Jane Austen jokes. Oh, they gave us a bunch of garbage. That's unreadable.
C large.
Okay, so we're going to create a /search. You go to /search, and it's going to do a search. So we're going to start the same way. Open the index. Right, it's all the same basic idea, except this time we're going to do index.search. CTX, that's the context, and then the query is going to be something like, what's an interesting query in here? Wipe. And then we go to the docs. Takes a query and options. Search searches the index for the given query. We'll just put nil for that. So we'll just do whatever the default search options are. That returns an iterator. So no error. Okay. We saw this with get, right, where it's going to be a pretty standard. You say .next. You give it the thing you want to fill, which is going to be a document. This is going to return a string and an error. The string will be the ID, and that's the error. If error is equal to, what do you think I'm going to put here?
There's not equal to string.
Search dot done
All right.
break else if error not equal nil. I guess we'll do this. But otherwise, that means we have a document and its ID. So I'm just going to print that out. Print F percent. So the ID is whatever, and the error, well, no error. So the document. Okay, so I created a search. Oh, it's just a search. That's not okay. Search. And then it goes to handle search. It's going to get the index and then do a search for the word white and then iterate over. So let's see what that gives us. Not very interesting because we only have one document and I searched for something that was obviously in the document. Let's search for something that's not. I suspect the word whale is not in there. It's a guess. I could be wrong.
Surprised. My wife is a whale.
It's not in there, so it didn't match. So the search.
I'm not speaking about my wife.
You want to remove that from the video?
My wife is awesome.
So return the entire, so with white, return the entire document?
Yeah, I mean, right. We only have one document, so it's not super interesting. So we're searching for the only possible thing we could find. Now, if you had 100 documents, then you might get something interesting. But
You type in the command line, and you type in search in the command line, and you've got index. You got like the index one.
oh, I was using the godoc command on the command line here. Godoc, you give it the package name and then the thing you want to read about docs for, and it gives you the documentation for that thing. You can also use godoc.org, same thing.
Can you get it to return a paragraph out of the document?
Okay, so let's look at the docs here. And I will use the godoc for this. I find the terminal is nice if you're just like wanting to find one thing, but then I like to use the website if I'm looking for more general stuff. Because this is easier to read on your browser. There's a bunch of things you can do in here if we have the search options. Yeah, so you can give it a limit, IDs only, and like I said, this faceting stuff, we're not going to talk much about that, but you can adjust what's returned, which fields to include, that kind of stuff. Okay. So often with a document like this, you might have the full document text, and then you might have a separate field for a summary. And then you could restrict to just the summary and show that. Or you may not store the full document text at all. I don't know if you can. So I know in Elasticsearch you can say index this, but do not store it. And then you can search for it, but you actually can't get the data for it. And the reason why you might want to do that is if it's a large amount of data, you don't want to have to store it in Elasticsearch. You'd rather store it in your on your file storage. But I don't know if you can do that with this. I haven't played with that too much. But yeah, you could have different fields and only return the fields you want. Any other questions about it?
Yeah, so if we scroll back down to those options, and there's one for the search options, there's one for, let me see, refinements. And that's where I get like a little confused when I read these comments. I feel like, I must not understand something, because it says, refinements are applied in conjunction for faucets with different names and then disjunction otherwise. And I read that and I'm like, I don't know conjunction, disjunction, or faucet.
Yeah, so facets are things we haven't talked about.
Yeah,
So that's probably not helping.
yeah.
But yeah, no, this is pretty technical. Who uses these words?
I know, exactly.
Mathematicians.
Professional search people are like, of course, in conjunction and disjunction.
The Google people wrote it, so.
I mean, it's kind of nice because it's like somebody who knew what they were doing built
Yeah.
it. But we don't have to use that. But I think it's like you can do a search and then you can further refine the search.
Yeah.
Okay.
Refinements make
And so I think the idea of faceting is where you do a search and it like gives you results, and then on the side, there's various groupings of those search results. And I can say, no, I didn't want everything. I only wanted articles, or I only wanted images, or I only wanted, you can do that kind of stuff, okay? That's faceting your search. Anyway. Any other questions about this?
So is there like a function to, you do the search, and then if you don't want it, you throw it away. If you want to keep it, is there like a save or
Yes.
like a different kind of filter in a query?
So you can do a data store too. This idea of the cursor. You can return a cursor and then replay it. But I think in general, don't do that. Just use offset and limit. And so you want to say you want to have multiple pages of results. You want to show the first 5 results, and then you click next and see the next 5. Do that with offset and limit. Okay. So you say the offset is 5, and now you're going to get to the next 5, right? Everybody understand that paging? It's pretty straightforward. I wouldn't mess with the cursor stuff. That's just confusing. But you could do that. You can save a cursor and replay.
Well, all that seemed relatively straightforward and simple.
Okay. So our exercise.
Now this doesn't actually seem straightforward and simple.
So we looked at open. What does open do?
It opens a new search.
It opens an index.
Index.
Yes. What does put do?
What's it?
Document in the
A
index.
document into the index. Let's get to
Get pulls a document by ID.
right by its ID. What is in search? We search for things, and then we didn't look at the week, but I'm sure you can figure out the week. So the problem we want to work on is we want to build a simple movie information site that has search capabilities. And so just require login, and then any user can add a movie, and then it should support searching. So the basic idea here is you're going to have a page with a form on it. That form's going to have title, give it a title, and then information or summary, and you can copy this from IMDb or whatever, and it's just going to be a text area, okay? And that'll be the paragraphs of, and then you'll submit. So text input, text area, submit. And now we'll add a movie to the movie information database. And then we want a search thing. So maybe at the top there's a search button. Go in there and search, hit enter, and it will search the blobs of text people entered for a specific name. Everybody understand?
Yeah.
So it's pretty straightforward as far as building HTML stuff. This time I have not provided you with a pre-canned website, so you're going to have to build it from scratch. But hopefully that's not too hard.
Crazy.
And I will help you. Any questions?